Yeah, how's it going, mate? I'm Obsidian Zenon. So, as you can probably tell by the state of my desk behind me and my monitor, I've been working on a new project, so here's the idea. I listen to music, right, on usually these earphones, sometimes some over-ear headphones, but I listen to music. But here's the issue. Sometimes I'm listening with both earphones in, sometimes with one, and sometimes the other. Now this presents a real problem, especially for songs which may have the vocals on one channel, maybe the left channel, and the music on the other right channel, or they could swap between them. This presents a real issue when I'm using one earphone, and I just wanted to be able to build a box that lets me control the left and right channels, switch them around, change the volumes, things like that. And I know you can do this in software, but where's the fun in that? Here's the basic rundown of what it's going to do. So it's going to be a box like this. We've got a power switch. We've got an invert switch, which swaps left and right channels. We've got balance knobs. They're just knobs that change the volumes of the left and right channels separately. This is actually a 3-position rotary switch. So it goes click, click, click in 3 positions. And it lets you pick from going stereo audio, mixing both channels into the left ear or the right ear. And we have an amp. So we'll have an amplifier, so we have a switch to be able to go either amplify it and then send it through this jack, and this is a knob to control the amplifier, or flip it up and it just comes out a plug in the back once we've changed all these settings here. And I'm also going to USB-C power it. I've just pulled apart a little plug that I'll just solder to the power connectors, because USB-C is very convenient nowadays. Yeah, so I will get a circuit going for this, and we'll see how we go. And here we are with a much better and more to scale design. The other drawing I just showed before was a general idea, just outlining the different functions it's going to have, but this is a closer, if not exact version of what will be the final product. So this is all to scale. This is in Inkscape, which is free and open source vector graphics software, but this is a to scale model, so everything here is 2-dimension. So this box size here is actually this instrument case in this JCar catalog. I didn't use a Jiffy box because I don't think it would have looked right for this purpose, so we're using an instrument case. We're using this one. And yeah, so I've just done that, and then I've scaled everything right, and you'll see, so we look at this light brown circle here, so that is a potentiometer. So if we look at a potentiometer, the light brown circle is going to be this bit behind the panel, because remember, you got to position things so that they don't overlap behind the panel. So the outer light brown circle is this base bit. The inner darker brown circle is the nut, the threaded bit where you put the nut, and the grey bit is the shaft of the potentiometer. As for everything else, we've got a SPDT toggle switch here for power, and that's an LED. We've got a DPDT switch here and here. That's another knob just with a big dial on the front. And this is the rotary switch I was talking about, stereo, left channel, right channel, mono. And that's just the headphone jack. Also on the back, I won't need to do a design for the back because there's no point, it's just 2 jacks and a USB port, but yeah, that should be it. I thought I'd show you a quick knock-up of hopefully the final front panel design, and I've just cut out an old kid's placemat and used that as a panel because I don't want to drill the proper panels just yet. But as you can see, this is kind of the layout, and obviously I'll cut the shafts of all the knobs and switches, but that is the general idea. Also, sorry for the noise, it is currently raining right now. Hey, check this out, this is sick. So I don't have the design on my computer because Windows deleted Inkscape, gotta love it, but I was originally planning to use some red Dymo embossing tape and just stick it to this front panel because the front panel is like rough, so I couldn't paint it or anything. So I was going to use that, but it turns out the embosses that you find today are apparently really bad, and the old ones are pretty much impossible to get, at least for a good price in Australia. So I was really struggling to figure out what to do, but then what I did, right, was I 3D printed some letters, and I lined them up on a piece of tape and glued them. You can see that's actually kind of wonky, but whatever, it doesn't matter. I'm not going to be staring at that much, but that is a very nice looking label, and it won't come off like paint because it's actually a 3D raised leather. It's only about 1/2 mil thick, but that's really good. And this is actually in line. It's in line with the first 2 potentiometers. So before I do any of the rest of the labeling, I'm gonna have to drill the holes for the switches and stuff first. But yeah, once that's done, it'll be really good. So I'm really happy with how that turned out. Check it out, the front panel is done, and I cut the potentiometer shafts to the right size, and I have to say it's looking much better than I ever thought it was gonna look. You can see you got the headphone jack down the bottom there, and I'll just give you a quick rundown. So you've got the left and right channel volume controls, just linear potentiometers, nothing special. The stereo left mono and right mono switch, the channel swapper, and obviously the amplifier gain. And this switch, so originally I was going to have this switch control either send the signal to the amplifier and then out the headphone jack, or send it to a line output on the back. But instead I've just got it switching the actual amplifier's output to either a headphone jack here or a speaker terminal, a stereo speaker terminal that's going to be on the back, but I haven't done that yet. But so far so good. Alright, so I finished the amplifier circuit, and I didn't record anything because it took a lot of troubleshooting actually, and that's a mess, so don't look at that. But I will show you how it works, but I'm going to put it in the enclosure first and do the back panel and put the front panel in and stuff first, and then I'll show you and make sure it works and everything. I just got back from my radio club. I've finished the amplifier, and we can just have a look around the back here. See, it's all plugged in, ready to go. I'm just going to demonstrate. So I've got it hooked up, so I have headphones plugged in, but I've actually got it hooked up to the speakers behind my room. So I'm going to switch this on. Now, I was going to play some 80s hits to demonstrate this, but YouTube probably wouldn't like that, so instead I'm going to play some classical music instead, which is just as good. So here we go. I'm going to try and demonstrate the different controls for this, but because it's a mono microphone, you may not get the full experience, but we'll see. So I'll turn this on. So here's our gain knob. And here's our left and right balance. Invert's not going to do anything here because I think this is mono audio, but So here's the finished product. Just look at the back side here because I haven't showed you that yet. You can see there's just a DC jack, these push speaker terminals. You just put a piece of wire in there, push this and it clamps it down, and that's the input 6.35mm TRS jack. And I'll just open this up so you can see the inside. And here is the inside. You can see I've got the perf board, I've got the amplifier circuit, that's the left side and that's the right side. That's the power bit, and you can just have a look at the back of the panels. And yeah, so I've got the circuit. This is the first bit. So this represents the control panel actually. So you've got the input from the back there, and it comes to here to the balance knobs. There's a 10k resistor at the start, and then these balance knobs, they're linear. They probably should have been logarithmic, but I'd only had linears at the time, so whatever. And that just changes the volume of each channel. Then this is the invert switch, dual pole dual throw, and it's wired like that to make it work. Then from here to after these DP3T switches is the left-right mono rotary switch configuration. And then this is the gain knob. Now the gain knob doesn't actually control the gain. It originally did, but it was too noisy because I've got metal knobs, so it actually, when I touch it, it creates some noise. So it still says gain, but it's really just a volume knob. We'll move up to the amplifier part. I'll just show you one because they're identical. So we just have the LM833 op amp, which is this one. It's a dual op amp, which is why there's only one, because the one's connected to here, one's connected to here. And it's feeding into a Class AB output stage with some 1N4148 diodes and a BC547 and 557. Those are two 10 ohm resistors on the output there. And that feeds off into the switch here, which switches between the speaker port and the headphone jack output. There's also the power circuit, which actually is pretty much identical to the Class AB output stage, but this circuit I ripped off the internet on a website that will be in the description somewhere. But the website that I got this circuit from actually was missing these two resistors, 10k. The value isn't that crucial, it just needs to be splitting the voltage in two. But it was missing those, and I was wondering why this circuit wasn't working. And it also used 2N2222 and 2907 transistors instead of BC547 and 557s. So I was wondering why it wasn't working there, so I had to play around with that a bit, so just be mindful of that. Just a little bit of smoothing capacitors on the output. And yeah, that's it. So I hope you enjoyed the video of me building my amplifier. I had a lot of fun making it. If you like the video, please make it known by pressing the like button, and I guess I'll be seeing you in the next video. See ya!